The first way we're going to solve systems of two equations is by graphing. Solving systems of two equations using the graphing method. There are algebraic ways too, where it's more like solving equations, but we can definitely solve them by graphing. So what we're going to do is find the solution by finding where the lines intersect. Where the lines intersect. So that point that they intersect. It's a good idea. I'm going to put a little asterisk here. It's a good idea to always check, because if your graph is just a teeny bit off, it's easy to be a value off. So let's solve the system where the first equation is x minus y equals 2. And then the second equation is x plus 3y equals 6. So to graph x minus y equals 2, let's do this one with slope-intercept form. So x minus y equals 2. Let me rewrite it with a little more space. So let's move the x to the other side. And then we'll have negative y equals negative x plus 2. Divide both sides by negative 1. So y equals, that'll go to a positive x minus 2. So to graph this, so I'm going to first start at my y-intercept of negative 2, and then I'll go up 1, over 1, up 1, over 1. It's important to get this pretty straight so that when I find the point where they intersect, then I know I'm accurate. It's the best way to make sure we're landing exactly on the right answer. Now for the second one, I'm going to go back over this in red. X plus 3y equals 6, and we'll do this line in red. So this one, let's do the intercepts. This looks kind of set up nice to find the intercepts. So when y is 0, this whole part's gone, 3 times 0 is gone, I'm just left with x equals 6. And when x is 0, the x part is gone, I'm just left with 3y equals 6. So divide both sides by 3, and I would get 2. So my x-intercept is 6, and then my y-intercept is 2. So if I connect these, so when I look at this, every single point on the red line works for the second equation. Every single point on the blue line, the first one, works in the first equation. So the only time when we have both equations working is right here in this intersection point. So that looks like that's the point 3, 1. So let's do a check to make sure this is our solution. So 3 minus 1, yep, 2 equals 2, that checks out. And then let's check the second equation. 3 plus 3 times 1. 3 plus 3, yep, that's 6. That checks out too. So it's good to always check, especially with graphing. So we got the correct answer of 3, 1 by finding where they intersect. I will point out that the special cases when we graph, if we graph the two lines and we end up having them be parallel lines, then it would be no solution. There's no solution. And then the other special case is if it ends up being the same line, sometimes the equation looks different, but it ends up simplifying down to the same thing. If you graph and it's the same line, it's an infinite number of solutions, because it's every single point on the line since it's the same line.